Hey class, let's look at an example or two of finding the slope of the graph of the function at the given point. Basically with these, if you were to graph the function given, locate the coordinates of the point given, and skim the graph at that one spot, the slope of that line, which is called a tangent line, is what we're ultimately after. It's very methodical on how you find this. Our first step is to take the derivative of the function. The derivative is the rate of change for any value of x. So let's do that. Okay, we'll use power rule and take it one term at a time. X to the fourth has a derivative 4x cubed. Negative 6x cubed, its derivative is negative 18x squared. 4x squared has a derivative of 8x. And negative 5x has a derivative of negative 5. The second step in these problems is once you've taken the first derivative, which represents the rate of change anywhere on the graph, then you specify the exact location you want your slope. For this one, we want to know the slope when x is negative 1. So we're going to find the rate of change at negative 1. Every value of x replace with a negative 1. Now you feel free to use your calculator on these. You don't have to grind them out step by step. I just do it because it helps explaining. Remember, order of operations, exponents before multiply. 3 negative 1s multiplied. 2 negative 1s multiplied. Now we can carry out the multiplication. Whoops, excuse me. I got a little zealous there. Grand total, negative 4 minus 18 is negative 22. Minus 8 is negative 30. Minus 5 more is negative 35. A second example, we have 2 times 4 minus x quantity squared. If you were to generate a graph of this function, locate the point 40, draw a line through that point that skims the graph, then that line would be your tangent line. We're just after the slope of that tangent line. And we're going to cover tangent lines on the next video. Let's do a little prep work on this one. 4 minus x quantity squared is 2 4 minus x's foiled. Okay, so 4 times 4, 4 times negative x, inside 4 times negative x, and last negative x times negative x. You get these 4 terms from the FOIL method. Distribute your 2. Negative 4x minus 4x is negative 8x times 2. So I combined these and then multiplied by 2. Now we can get our derivative. The rate of change anywhere on the graph is f prime of x. 32 has a derivative of 0. Negative 16x has a derivative of negative 16. And 2x squared has a derivative of 4x. Again, your first derivative represents rate of change at any value of x. We're looking for specifically the rate of change or the slope at 4 when x is 4. So f prime of 4 will give us the rate of change or the slope of the graph when x is 4. Well, that comes out to 0. So what that means is if you were to graph the original function at the point 4, 0, because the rate of change is 0, you would either be at the top of a hill or at the bottom of a valley. Later in the class, we'll learn how to determine which case that is.